Hello everyone, this is Akash. Can anyone please write on the chat channel if you guys are able to hear me, if audio is working perfectly fine? Hello? Is audience able to hear me?
Akash, I can hear you.
Yeah, Murugan, just let them respond. Murugan, let's wait for a couple of minutes. Okay, I guess the
Sure,
people
yeah,
are joining.
yeah.
We'll see. Okay, great. So I saw the Krishna Prasad saying that he's able to hear me. Let's wait for a couple of minutes and then we'll start.
Sure.
Okay, so let's start. So thank you guys, everyone, for joining today's webinar. My name is Akash. So today our guest speaker is Mr. Murugan Palanicherry. So he's basically a blockchain consultant and DevOps specialist at Pingala Software. He also organized a meetup group called Bangalore Blockchain Developers Meetup Group. So today we'll be talking about the building blockchain DApp with Ethereum, Truffle, and Web3js. So Murugan, it's over to you. You can share the screen and start. Thank you.
Cool, awesome. Yeah. Thanks, Akash. You able to see my screen now?
Just a minute, it's loading. No, Murugan, I'm not able to see your screen. Can you please share it again?
I stopped share and share it again. Let me do that. Yep. How about now?
Just a minute. Yeah, we are able to see your screen.
Okay, all right, cool.
Yeah.
Okay, let me know if there is any delay. Okay, yeah, let me get started. So thanks everyone for joining. I think Akash has given a good introduction about me and then the topic as well. How we are going to take today is, I'll be talking about just a little brief overview about blockchain and Ethereum. It's a very brief overview. And then we will get into building a DApp. We will build a complete application. Basically, it's a pet shop where, we want to, anyone can adopt a pet through this website. So this application is entirely built on blockchain. We'll be using Ethereum as a blockchain here. So let's see how Truffle and Web3js helps us to make it easier to build dApps. I think I don't need any introduction. I think Akash has mentioned about me. So these are my some of the meetups which I host, and you guys can actually join them. These are free meetups. And then moving on. So how blockchain works, right? Let's take a scenario. We take Uber, right? Where we actually, what we're doing is when we took an Uber, we pay money to the Uber, and then Uber pays money to the driver, right? And the biggest problem here is the person who's actually working hard and he's not getting the full money. But we as an end user, we are paying more money than what the driver actually takes. So what is happening here is, so the money in between, the person who sits in between, let's say Uber or Ola, anyone, right? They are taking the share of it. So there's actually intermediary person, someone sitting there. So what blockchain is trying to do is it is trying to eliminate all the central entity and then do a peer-to-peer transaction. Now, if I were to rewrite the Uber or Ola application in a blockchain, then I would rather pay directly to the driver. So we're eliminating the intermediary person, and then even the cost of the ride will also be reduced. So how does that work, right? Let's take in this picture, I have built an Uber application in the blockchain. Since there is no central entity, that means there is no central server as well. There is no Uber. There's no something called Uber. They are maintaining server. There's no any company who manages this application. Blockchain Uber is what I'm naming it as. So the way it works is, now let's say I as a end user, I book for a ride, and when that particular request goes, that particular request will go through the nodes. Okay, these are the multiple nodes running on the network. These are public nodes. Okay, these nodes can be run by anyone, any individual from anywhere in the world. I can run one, and even you can run one node. So once a request goes in, so one of these guys will actually mine it and process it, and then they add that transaction, and then they create a block. So once that block gets created, that means they're confirming my request, and then that particular block having multiple transactions, because it can take others' request as well, and then the block gets added into the blockchain. So, and this particular blockchain will get replicated across all the nodes in the network. And then once this is done, and I actually get the confirmation, and then I can actually take the ride. And similarly, when I pay the money as well, and it goes, and then the driver actually gets the money back. So this is how entire blockchain works. It's a peer-to-peer network, and it's processed by no central authority. So let us look at some of the characteristics of blockchain, right? It's a distributed ledger. So basically, a ledger is nothing but you have a paper, and you're just making a note of what all things happen. Now in a blockchain, what we're doing is that same entry, we made it to the ledger. We're keeping a multiple copies with multiple people. In this example, that particular ledger entry will be kept with everyone in the node. So what is the beauty of that? Because that is not owned by anyone, and then we also don't know who owns that particular ledger. So for an example, if we were to ask a politicians that, okay, where did you spend money, let's say let's take an Indian government, right? We question them. How did you spend money for this 2017 or 2018 now? And then what they might come up with saying, I've spent money here and here, and all the details, right? Now the problem here is, how can we actually verify that? How can we trust that that particular result, whatever they're giving how can you trust that, right? It can be, because since it's being handled by a central authority and they can actually modify it. So rather, if we were to rewrite this in a blockchain world, so every transaction or every money spent, that will be that entry will actually go and sit in the ledger, and then that ledger is available with the multiple people in the network, and no one can actually modify it. So whenever you ask for the how much money we've spent so far, and you will get the right money that's spent. You'll not get any fake information there. So that's the beauty of having a distributed ledger. And another main concept here is immutability. Whatever data goes and sits into blockchain, you cannot change it. Okay, you cannot change it. You'll rather keep updating it, but you can never change any data in a blockchain. And it is decentralized. So nothing is centralized. Like I said, there's no central authority here, and everything is decentralized. It's not owned by any company, anyone. And this also uses encryption methodology, right? And you can actually, when you do any private transaction, you can actually encrypt your data. At the same time, we keep it transparent. But if you actually, for example, if you open Etherscan, you will actually see, this is actually the Ethereum, the production network, right? And when you log in here, you can actually see what is happening. There is no hiding. You can actually see everything here. In Etherscan, there's actually production version, right? Now, what is it? The recent block they mined, and what are the recent transaction happened? Let's say I click on this recent transaction. So what is the hash? Who did the transaction? What was the transaction is all about? So every detail is kept transparent. It's a public blockchain. Another beauty of blockchain is with Ethereum mainly, right? A lot of other frameworks also come up with this concept called smart contract. So what is smart contract? Let's say that India want to import goods from Amsterdam, let's say, right? So, and that particular goods, maybe fruits, let's say, okay, that goods takes around 1 week to reach India. Now, a factory in India will have a contract with the Amsterdam guys telling, okay, you do this, you courier fruits to India, and then I will be paying you so much of money. Let's say that, once you actually, you got the goods, and then you actually see that, and then some of the fruits are actually, it's damaged, because they didn't maintain the proper temperature while transporting, or they didn't maintain, or they made some mistake while, loading it or unloading it, or some problem, or someone would have done it. But then the problem here is non-blockchain things. How do you prove that the fruits is actually damaged? Or in the other way, right? Now what will happen is the Indian factory might say, I will not pay you the full amount. I will pay you only 90% of it. 10% will not pay you. That might be one case. The other case also, what if you already paid in advance? And then at the last you might ask, no, you take 90%, pay me 10% back, because there was some fruits which it's gone or damaged, whatever. So to avoid all this problem, so within Ethereum, we write a smart contract. So the whatever rules we have agreement, basically, those agreements, we write it in a program and then deploy it into Ethereum. So basically it's like if else condition. Okay, so if the fruit is in this condition, and then pay so much. If the fruit is in other condition, then don't pay, because you cannot use that fruit anymore. So likewise, so you can write multiple conditions, and then you can schedule the date also. Okay, so the money will be deducted from this account on 5th day or a 10th day, like that. So you can actually write all the conditions. Another beauty of blockchain is traceability. If you take an example of Hyperledger Fabric, what Walmart is trying to do is, they want to trace the perishable things, right? Let's take a mango, right? If the mango is deceased, and blockchain, if you keep the information of how this supply chain of how the mango is being produced from day one till the consumer, right, till the agriculture, until the end user, where all it has gone, you can actually trace back where exactly the mistake went. So the traceability is very beautiful. So moving on, so within Ethereum blockchain, this is just an overview, guys, and I'm not going to go detail about blockchain or Ethereum. Okay, so in Ethereum blockchain, it kind of looks similar to the previously what we saw in the blockchain. So in Ethereum, it's similar, and you have the public nodes running in the network, and then people mine a request, and again it maintains the the ledger, and I mean everything remains same. Now, so this, I think we spoke about smart contract, right? So few things is in Ethereum, so we write smart contracts in the language called Solidity. So this is an example. This is how a Solidity program will look like. We will actually write a Solidity program. Yeah. Now, moving on. Now, so what we want to do now is let's write a smart contract for the pet shop. Okay. So what we're going to do now is this is a pet shop. Okay. So this pet shop can accommodate up to 16 pets, and anyone can actually adopt the pet. Okay. Now, within a blockchain area, like, if you want to know who's a person will be adopting it, or if you want to identify anyone, you will not have a user ID, password, anything like that. Rather, you will have their address. Address is the unique identification of anyone. So to adopt any pet here in this website, people need to log in with their address. What we will do, the easiest way to write, smart contract is just use IDE, the web IDE called remix.ethereum.org. Okay. Now, in the beginning, you'll see something like this, and just maybe discard this content here. So I've already written these smart contracts. Let me just pick it from there. This is my contracts and adoption. Yep. Okay. Let me just this here. Okay, I think the version. Okay, forget it. Maybe I'll show that in my editor itself. So what I'm doing here is the Solidity programming language. To begin with, you should actually mention this pragma and then the Solidity as a keyword, and then which version of compiler we are using. So here we're using 4.17 is the version we'll be using it to compile. And when you want to create a contract, smart contract, this is same like creating a class where we say class and the name of the class. So similarly, we just mention a contract and then the name of the contract. So here, the name of the contract is adoption, because we'll be adopting the pets, right? And then just again open curly brace and close curly brace. Solidity gives you option to have default data types like string, integer, other regular Boolean, regular data types. And apart from that, there are some interesting data types or address data types. So, like I mentioned, to identify anyone in the Ethereum world or in the blockchain world, you'll have to identify them with their address. So that is why this is a unique data type to store anyone's address actually. Now I'm creating it's a public specifier, and then I'm creating an array of this. Now this is similar to class where you'll have your variables and then you'll have your functions. So here we have only two functions in our smart contract. So the first function is when someone adopts it. Okay, so when someone clicks on, okay, I want to adopt this pet, right? What happens? So when they want to adopt any pet, they will have to pass what is the pet ID, okay? And once they pass the pet ID, so what we will check is the pet ID should be greater than 0 and then less than 15, because like I mentioned, this pet shop can fit in only 16 pets. That's why we're just making this condition. So when you put this require, okay, so what happens, unless until this particular condition satisfied, only then it will execute the next statements. So once this satisfies, and then what it will do, it will actually start adding this, the message.sender. So when you do this, you will actually get the address of the person who's actually want to adopt. Now we are adding this particular address of that person who want to adopt to our variable here, adopter variable here, with the pet ID, and then just return in the pet ID. So this is just adopt. And then one more function what we are doing is, okay, we also want to show in the web page, once the adoption is done, other person cannot adopt it, right? We want to disable the adopt option. So this particular get adopter, it will just public access specifier. I mean, others can actually view it from outside, and we are returning the view, and then we are returning the address of it, address of the users. So this will actually return all the adopters. So it's a very simple smart contract. So usually in Solidity, the smart contracts, if you see, you might be solving a very bigger problem, but then your smart contracts might look very small. Okay, now this smart contract is done, right? We have written this smart contract. Now let's move on to the Truffle part. How Truffle can actually help us. Just building these apps. So the beauty of Truffle is, setting up a new project for Ethereum project, or compiling the project, or deploying the project, and a lot of your operations and all those things, right? That is made easy with the Truffle. So Truffle is the most powerful development framework for Ethereum with the mission to make your life a whole lot easier. This is from the Truffle website. So what all it can do, smart contract lifecycle management, starting from creating this smart contract, compiling it, deploying it, migrating it to any Ethereum. It can be your public Ethereum as well, and even in the private Ethereum as well. Like if you, let's say you have your Ethereum network running on Azure or AWS anywhere, right? And you can use Truffle to migrate your smart contract to there. Now, so what Truffle also has is something called Truffle box. Okay, so the beauty of Truffle box is this is like it is kind of it creates a boilerplate for you. Like if you want to build a React.js application, okay, and then it gives all the React.js necessary files. Or if you want to create any Azure related application, then it gives you the sample. For example, let us take a look at this, right? For example, Drizzle, React with auth. There's a lot, and you can actually use a lot of these boxes. So what we're going to do for this today's webinar is, we will create this pet shop. Pet shop is actually one of the box from Truffle, that is actually available to anyone to go download it and start to play. You can play with that. Now, how do we do that, right? So to play with Truffle, so what we need to do is, first thing is we need to do npm install -g and Truffle. Okay. So since I've already done it, so I'm not going to do it. So it's just like this: npm install -g and Truffle. So this is going to install everything. This works similar with your Ubuntu or a Mac or anything. I'm running with my Windows computer today. And to run Truffle, you need Node, you need Git as well. Okay, make sure your Node is installed. Okay. Yeah, my Node is running. Yes. Okay. So and then make sure you have Git is installed. And then what we do is we will let's create one folder called pet shop or anything. So what I've done here is let me just go here and show you what I've already done. So because I don't have so much time to do everything from beginning, that's why I'm actually showing it which already done. So I have created a folder called Truffle sample. Okay, Truffle sample is my folder. So I've actually cd into the folder, and then so to download this, the boilerplate from the pet shop. So we enter Truffle, unbox, and pet shop. So this particular command will actually start downloading all the the pet shop samples. Let me, so for example, I've cd'd into Truffle sample. Earlier it was project, it was showing error now. So now Truffle unbox pet shop, if I do, and then it is telling me like downloading, unpacking, setting up, it is successful. And then it is actually like, it's showing, some of the commands, what you can actually use with Truffle. So Truffle compile, Truffle migrate. So we will actually go in detail in the next steps. So we unboxed it. So the moment you actually execute this particular command, so what you will actually see is so this particular code, like whatever code I'm showing here, it's available in GitHub. This is actually it's a Pingala software GitHub account. You guys can actually go ahead and download and play with this entire project, complete project. And if you want to go step by step, if you want to follow, then you can even in the Truffle website itself, you can actually follow along the tutorial section. Okay, so once we unbox the sample, what we see is this a major directory structures. So we will have a folder called contacts. So this contract is the directory where we keep all our smart contracts. All our Solidity files will be kept here. .sol is the extension to for smart contracts. For example, if you see here, contracts in the folder, and then migration.sol, adoption.sol. So all the smart contracts will be kept here. And the migrations. So migrations is an important folder for Truffle. Okay, so this is the folder where we keep files in order to once we deployment. So for deploying, so here we call it as a migration. So basically, migration is moving from here to the public network or private network or any other blockchain network. So we call it a migration. And then one more folder, test. So it's always good to write a test, whether it's a blockchain or non-blockchain application. So so there's a folder called test where we can actually write you can use any testing frameworks to test. And then also Truffle itself provides testing functionality. We will see that in the coming slides. And another important thing is Truffle.js. And this is where you actually do a lot of configurations. Let me show it here in the project. So we have seen this, the contracts. So now we have this adoption contract, the migration, just default. These are the migrate to when we migrated. And let me just close this once again before I come there. Yeah, this is a test folder where we run a test. And yeah, so Truffle.js. So okay, so in the Truffle.js, so this is where we actually mention which network we would like to connect to. So for now, what I'm doing here is I'm actually connecting to my local Ethereum network. Okay, so this is it's running 172.0.0.1, and then it's running on this port 7545, and I'm using a Ganache for that. Okay, it is actually, if you see here, this is my local node, local Ethereum node is running. I'll come to this later. Okay, and otherwise this project, what you see here, it's the node application. That's why you see package.json. This is just regular node application. Okay, and since what we are building here is we are writing a smart contract, and at the same time we are building the web application as well. So that means we need to have a UI and other applications, right? So this SRC folder has some of the the projects here where you have a HTML page and then your app.js. This is where you'll write all your business functionalities. And otherwise, other CSS. It's just a web project. And then we'll see how this web project is actually will talk to Ethereum, because Ethereum is altogether different, and then you have a web application that's actually running differently right now. Who is helping you to talk to blockchain, Ethereum blockchain? That we will see in the second half. Now moving on. Yeah. So I think I've shown you this, right? So we need this. This is must. This particular host. So what you do is, so Truffle provides you Ganesh. Let me go here. Okay. So you just download this Ganesh. Okay. So once you download it, and then once you run, so what it actually does is it creates an account for you. It will have like these many accounts it already default it creates, and these are free of cost in the sense these are not a real Ether. Okay, so this is just to have a local network running your laptop, and then that gives you default accounts, and also each account will have like 100 Ether. Okay, it's not 100 because when you do any transaction in Ethereum, you need to pay for each of the transactions. So some of the transactions which I've done, so it has actually deducted some of the Ether. So it gives you free address, this many accounts, and then each account having this many Ethers. And then this beautiful UI where you can actually see, how many blocks have been created. See, so far, if you see here, this is 14 block has been created with this particular application, the application which I ran. Okay, so the same application created so many blocks. Okay, and that shows, what is the server, the RPC server. All the communication happens through just an RPC. And this also shows you what are the transactions happened, when other transaction happened. See, contract creation, and there's a call. Yeah. So there's two things here when we actually invoke any smart contracts. One is the transaction, another one is a call. So whenever you do any transaction with Ethereum, you need to pay the fee. You need to pay the gas. You'll pay through Pay. That's the lowest denomination of an Ether. When you do a call method, right, that means you're actually reading some information, then you actually don't pay anything. So that is free. You don't pay for it. This is it about Ganesh. Just run it locally and then make sure it shows it is running. Okay, it's a mining status. Okay, we need that because we'll be connecting to that. Can actually see what all it can do. Truffle. Okay, so now we are running the Ganesh, right? Okay. So what next, right? So now let us move on to the same thing here. Earlier, very first time when you do this unbox, when you do Truffle unbox this pet shop, you will not have this particular file. Adoption for contract won't be there because it just gives you boilerplate, right? So now, because this boilerplate can be used for any other application as well. So it will not have this particular file. So you will have to create a new file, adoption.sol, and then start adding this particular, start writing your smart contract. So I've explained what it does before, right? It just does a two functionality. One is, where people can adopt the pet. Another one is to retrieve, the pet, the owner's pets detail. This is being done. What's the next step? So now, once the smart contract has been written, right? Now we have actually written the smart contract. So now, next thing is we need to compile that. Okay, and to compile, Truffle gives you an option like Truffle space compile. Where am I? Okay, yeah, this is the keyword. Okay, so we can actually use Truffle compile. So when you want to work with, if you're on a development environment, you can say Truffle develop as well. So where you can actually execute all your functions and methods within your terminal as well. So now what we do is here, since it's already running and I don't want to stop it. Okay, maybe let me just. Okay, maybe I'll do one thing. I'll stop the application is running. Okay, now I'll compile. Okay. Yes, so it is done. So now what happened the moment when I said Truffle compile, it went on to this adoption.sol and it started compiling my smart contract, and then it created, this adoption.json. This is our application binary ABI, right? This is nothing but, showing our smart contracts in the JSON format. Here we can say, okay, what is a contract name and what is our ABI completely? What are the names we have and what are the functions it can do? See, if you see here, we have this one adopt function, okay, and then we have get adopter. So all other details like, it has a bytecode as well. It gives you all the details. So this particular adoption.json file, this compiled file, we would need it, once we when we want to interact from our web, from website, when we want to interact, when we want to talk to this blockchain smart contracts, we would be making use of adoption.json. So we'll not be making use of the adoption.sol. We'll be making use of this particular JSON file. Okay, all right. Now, after this, so after compiling is done. So next step is deployment, right? So with respect to deployment, you can call it a migration as well. So what we actually do here is, we need to create a file called, to_deploy_contract.js. So we create this particular file in the migration folder. Okay, and then here we need to mention, which particular smart contracts that I want to migrate it. Right? For example, let's say if I have 10 more smart contracts here, then if I don't want to deploy all the 10 smart contracts, then I have to mention it here. So rather here in this particular thing, I'm just telling, okay, so go get this particular adoption smart contracts, and then only deploy this particular adoption smart contracts. And this is same whether even if you're deploying it to private network, public network, a local Ethereum network, or anywhere, because all that it depends on from the Truffle configuration. So whatever you have mentioned here, based on that, it will work. If you're using a production and then you mention it in Azure link or any AWS or any other one. Okay, so once this is being done, so what we actually do is we say migrate. Okay, awesome. So it is telling using the network development, and network is up to date. Okay, so all the this thing has been deployed. Now, so for what we have done is, I'll just quickly. So we have written these smart contracts to adopt. Okay, and then we have created this sample, the boilerplate. And then that boilerplate as a UI, we will come to the UI later. And in the Truffle.json, we have mentioned it is a Ganache local network which is running here. And we have compiled our smart contract, and then we have deployed our smart contract to local Ethereum so far. Okay, so far that is being done. So I'll move on. Now, let us test, our smart contract, right? The smart contract, we have two functionalities, right? One is adopt, and then another one is get adopters. So how do we do that? So the Truffle gives you option like Truffle test. It's a very simple. Truffle build, Truffle develop, Truffle migrate, and Truffle test. It's very beautiful. It's so easy actually. Truffle test. Okay, so before that, let me show you what is a test. So initially, when you create that, when you unbox it, you will not have this test file. You'll have to create this. But anyhow, I've uploaded all this project into Pingala software GitHub page. You can actually download from there. Completed one. So test adoption. So here, this is where you just write all your test cases, right? I'm just telling you, I need the assert, and then I need my adoption smart contract, whatever you need. Just import regular. Then what I'm doing here, which I'm just telling, okay, test user can adopt the pet, check whether can he adopt it or not, and then get the adopter address by pet ID, because since we are storing, if you remember in the smart contract, so we are storing the detail of when someone adopts with their address, right? So here, if you see here, with the pet ID, and we are storing with their address. So we just check, okay, we're checking, okay, whether if this is an equal to this, and then yeah, okay, and then also retrieve if you want to get all the pet ID address, and then use just a 3 tests I've written. So just say truffle underscore test to run all your test cases. I hope it runs. Awesome. Perfect. So all the test cases are run, right? It's good always, to write. And another best thing is to write is, if you follow TDD approach is another added advantage. That's instead of writing the test at the last, and you write the test first, and then you can write the code later as well. Awesome. Okay. So now we saw how the Truffle test as well. Then we are clearly telling that yes, it is working as expected. All the functionalities. And this is a file which is saw. Okay. Now, so far what we have done is we have written the smart contract, and then the smart contract has been deployed to Ganesh local network, right? So now this is like in a vertical way, we can call it as our database part is done now. Okay. Now we need to build our UI, and then we need to find a way to the UI will talk to this database. Database is the blockchain network, right? Now, so within the Ethereum world, so we have something called Web3.js. This is actually official from Ethereum. This is a collection. This is a JavaScript API where you can actually talk to Ethereum network. Okay. So how do we install? Same thing like with the npm only. Npm install Web3. So once you actually install npm install Web3, you'll be able to talk to any blockchain network. Let me show you some of the examples. Okay, network. Yeah, okay, fine. So now, for example, I have written this. Let me do this. Start commenting it. Now what I'm doing here is, once you do the npm install of Web3, Web3 is available here, and this will actually, it creates an instance of it, and then it goes and connects to the network. So this is where we mention, I'm creating the object of Web3, and then, I'm telling, okay, connect to this particular network. Now here we can actually see here, I do console.log 3. Yeah. You'll be able to see all the methods, functionalities available in the Web3. to see all the even the currency details as well. Now, this is one. What we saw now is, we were trying to connect to local network, right? Now, how do we connect to the real network, right? To connect to real network, one is you can install Git and download the entire network into your laptop, and you can start working with it. Otherwise, there's another option called Infura. Okay, so we have something called Infura. So where you can actually connect to that. So what you can actually do, log into the Infura. You need to create an account. Once you create an account and you say create a project, okay, and then once you create a project, you get this main network, and then just copy this main network address, and then this is my network, and I've already pasted it. Okay, so now I'm telling okay, go connect to that particular network. Okay, just now. Okay. Now this is connecting. Let me uncomment this. Okay. Now, so once this will connect to my main network, right? So what is the main network? It's nothing but Etherscan here. Okay. Now in the Etherscan, just going here. When you go to Etherscan, you can actually see all the details. You can actually see what are the information about what are the transactions happened, recent transaction, what is a block detail, few uncle pending transactions, what are the other ERC20 tokens are available, all the tokens details, right? So since these are public and transparent, and you can actually open any of the chain, any of the token, and then with their, say, this particular token is the end of the day, it is again, it is a smart contract. So if you see a contract, and this is a smart contract. Now you can take this address, and you can actually read through, what is the contract they've written. It's all public. Then if you keep paste it here, yeah, and then if you run, for example, let me run this. Awesome. So yeah, see, it got all the detail now, right? It did two operations now. One is it went to this particular address and got the detail, and then another option is, so it uses like this web3.eth.getBalance and give the address of that ID, and you get the detail. And also you can even get the block detail as well. So like I mentioned here, you can actually see all the blockchain detail right here. So all these data can be read through this. And this is just a call operation, so it doesn't cost you anything. So similarly, this particular Web3 gives you more options like utilities and versions, providers. You can connect to multiple providers as well, and some of the modules. So that gives you a lot of operations. I don't have time so much. Let me just go a little fast. Okay. Say to work with contract. Smart contract. Now, if you were to deploy a smart contract to Web3js, so we do something like this. So I create an object type, this Web3, and then this is my application binary interface. We saw the ABI, right, in the basic JSON file. So you have everything, okay, the complete ABI. We keep it, and then you create this instance of Web3, and this is to my main network, main Ethereum network. I've given the Infura link, and then this is the address. And then I'm telling, okay, create an instance of it, web3.eth.contract. Okay, and then I'm passing the API and then the address. So boom, and it actually creates the contract for you. We saw accounts, right? Yeah. So accounts, to get all the accounts data, right? And so we can directly use like this as well. Web3-eth as an account, so that you're directly assigning the variable here and create a type and then connect to the network. And then if you say, accounts.create, so this function allows you to create a new account. And then you can similarly retrieve accounts, and you can do a lot more. Now, so coming back to our Ethereum, the pet shop, right? So what we need to do is now, since we have already deployed a smart contract, let's go ahead and create the UI, right? So now you will have all these files when you unbox it. Only thing is, in the app.js file, this content won't be there, like what we need to do here. So in this particular page, what I'm doing in the first page, it will just fill all the pets detail. Let me show you, how it will actually look like. You'll get an idea. So this is how it will look like. This is what the website, what we're trying to build. Okay. So I'm saying, okay, these are the pets. Go and display it, and then in my now next thing what I need to do. So I need to initiate the Web3, right? I'm initiating the Web3 here. So once the Web3 is initiated here, so what it does is it is trying to connect to your network. So what it actually uses, it uses MetaMask. Okay, I'm sure you guys know about MetaMask. MetaMask is the wallet to interact with Ethereum. This is a Chrome extension. Just install it and create an account. So you will have the code, and you can actually talk to the main network as well, the production network, and then you can create your local networks as well, or any other test network. Okay, so once that is being done, and then next I need to initiate the contract, right? Smart contract. So now once I did a compile and then adoption.json file, I got an entire API, right? So here I'm creating the instance of my smart contract. Second step. Once my smart contract instance has been created, now I need to call the call the smart contract function, right? So the function is adopt function. So the way we call is app.contracts adoption.deployed. Then we're creating the instance of it. Then we say get adopter. Okay, the get adopter function. And if you notice here, I'm using something called call here. That means it doesn't cost you anything. This is to get the detail of all the adopted pets. Now, when someone want to adopt, right, this is where the money goes in. Okay, so in this function, I'm telling, okay, web3.eth get accounts, which this is to get the detail. And then I would say, okay, adopt this. I'm calling this particular adopt function. When I'm calling this adopt function, and then pet ID, and then which account also I'm telling, and this will take money. Okay. Now we have written this completely thing. Now, so then I'm just going back to my presentation to see. Yeah, we need MetaMask. Okay. And then, so now let us run our application, right? So npm run dev. Okay, awesome. Yeah, it's running now. Okay, now if you see here, these are the things that are coming from blockchain. All the information over here. So what we have done here is now when I click on this particular adopt function, okay, now this will invoke the smart contract which we have written, and then so to adopt the pet, we need to pay, right? So any transaction if you want to do with the Ethereum, you'll have to pay for it. So that is why we need to make sure that our MetaMask is running. And also what we need to do here is when you install MetaMask, you'll have main and Robster and all those things. So basically, you need to go to like custom RPC. You need to select custom RPC and make sure you enter this particular the network, the local network, and then save. Okay. Once it is done, and then it will start showing like a private network. Okay. Now, if you click on this adopt, right, and see this, now this MetaMask is actually opening. And then now here you can say confirm. So your transaction will be processed. And once the adoption, once you're done with the purchase, if you already adopted the pet, and this adopt function, adopt button will be disabled. So back to here, and yes, that's it. Now we have done with the complete thing.
Hey, thanks, Morgan. Yeah, that's a pretty good information. Let's go to the questions. Guys, if in case anyone has any questions, please write it down onto a chat channel so we can take it with Morgan. So Morgan, before anyone will be sending the questions, as of now, I can't see any questions in the chat channel, but before that, I do have few questions.
Okay.
So first thing is, I can see you deployed basically into a local host, right? If I want to deploy this smart contract onto the cloud, uh, what are the things I need to basically consider?
Okay, so in the package, in the truffle.js, we saw, we have given the local host address to deploy, right? Now, if you want to migrate it to, let's say, the cloud environment, right? So you will have the RPC connection from Azure. So you just need to put that and then use the same command like truffle migrate. It will actually deploy into a private network.
Okay, good, great, great. Okay, let's. Is there any other questions? Okay, so Murugan, as of now, I'm not able to see the questions. Okay, in the chat channel, it's pretty good information onto the conceptual wise also and the practical wise, because I can see all the codes and I do relate it with that. So
Yeah.
thank you very much for your time. It's really great information. And for audience, just this video will be available on YouTube on demand, so you guys always can verify this.
Awesome, cool. Thank you. Thanks a lot, Akash. Thanks everyone for joining me. And then I just want to, want to mention this. Go to the truffle.com and then in the tutorials, and there are a lot of boxes are available. Just play with some more boxes. If it is a React fans and any other things and anything like they have a lot more boxes there. You play with multiple, the dApps. I think you'll be very much comfortable and build any app with Ethereum. Yeah. With this, thank you all. Thanks for joining, and have a good night and have a good day for people joining from outside India.
Thank you, Murugan.
Bye. Thank you.